something extraordinary is happening above our heads. Earth is about to be struck by a stream of solar wind moving at more than 700,000 kilometers per hour. A blast of charged particles erupting from a vast trans-equatorial coronal hole on the Sun. At the same time, the interstellar comet 3I, Atlas, the third visitor from beyond our solar system ever recorded, has vanished behind the Sun without warning. Some experts are calling this moment a perfect coupling event, a rare alignment when solar and planetary magnetic fields open wide, allowing cosmic energy to flow almost unhindered. And as this unfolds, a sudden surge in powerful earthquakes across the Pacific Rim has sparked debate over whether all these events are connected or simply coincidence. A coronal hole isn't an actual hole in the Sun, but a region where its magnetic field lines stretch open, no longer looping back to the surface. In these zones, the solar atmosphere thins and plasma escapes freely into space, creating highways of charged particles. Normally, these magnetic loops trap the Sun's energy, but when they open, they act like a vent, releasing solar wind at incredible speeds. On imaging from NASA's Solar Dynamics Observatory, these regions appear as dark gaps sprawling across the solar disk. When one of them crosses the Sun's equator, it becomes what physicists call a trans-equatorial coronal hole, capable of channeling energy directly toward Earth. In late September 2025, a massive structure like this opened up. Instruments detected a steady stream of solar wind exceeding 700 kilometers per second, a blast powerful enough to compress Earth's magnetic shield and trigger intense geomagnetic storms. The orientation of the interplanetary magnetic field at that moment pointed sharply south, the perfect opposite of Earth's northward magnetic field. When those opposing fields meet, they can snap together in a process called magnetic reconnection. It's like unlocking a cosmic gate, allowing solar energy to pour directly into our magnetosphere. The results were immediate. Satellites recorded voltage fluctuations, communication systems wavered, and the skies above the northern hemisphere erupted with auroras visible far beyond their usual latitudes. Curtains of green and red light shimmering as far south as Michigan and Maine. But to scientists, this wasn't just a light show. It was a warning that Earth's magnetic defenses were fully open, and that even small fluctuations in solar wind could now ripple through our planet's electrical systems. As this unfolded, something even stranger happened. The interstellar comet 3I, Atlas, a mysterious visitor that had captured the world's attention, disappeared behind the Sun right as the solar storm peaked. 3I, Atlas was already an anomaly, smaller than a kilometer across, yet unusually active. Instead of the typical water-driven vapor seen in most comets, its outgassing was dominated by carbon dioxide, almost 8 times stronger than expected. That chemical signature suggested an origin far beyond the frozen frontiers of our solar system, perhaps from another star entirely. Spectroscopic studies revealed that its coma was rich in heavy carbon compounds and that its tail was faint, asymmetric, and built from coarse dust grains rather than fine icy particles. It was, as one mission scientist said, a messenger from another star system carrying a recipe we've never seen before. But when the comet passed behind the Sun, all observation stopped. For several weeks, it became invisible, hidden in the solar glare just as the most violent solar activity in months erupted across the same region of space. Then the ground began to shake. Within days, a cluster of magnitude 7 earthquakes struck along the Pacific Rim, from Japan to South America. Social media lit up with speculation, linking the solar blast, the comet's disappearance, and Earth's tremors. Scientists, however, urged caution. Statistically, the number of large quakes that week was within normal limits. Earth averages around 15 of that magnitude every year. There's no proven physical link between solar storms and tectonic movement, and decades of data show no consistent pattern. Still, for many, the timing was too uncanny to ignore. Now, as the Sun's storm begins to subside, Astronomers are preparing for the next phase, the moment 3I, Atlas re-emerges from behind the Sun. 4 possibilities are on the table. It could survive intact, returning to view with a steady, predictable brightness. It could fragment, breaking into a train of smaller pieces like so many comets before it. It could go dormant, fading to near invisibility as its surface seals shut. Or it could be gone entirely, disintegrated by the Sun's heat, leaving only a faint dust trail. In the coming days, solar observatories like SOHO, Stereo, and the Parker Solar Probe will begin transmitting new frames, one image every few minutes, as they scan the region where 3I, Atlas should reappear. Around the world, teams of professionals and amateur astronomers will sift through each pixel, hunting for the first faint glimmer of the interstellar traveler's return. If even a single point of light is found, telescopes on Earth will immediately swing into action, measuring its brightness, color, and motion to determine what survived. Whatever happens next will mark the end of one mystery and the beginning of another. A solar system on edge, a rare magnetic alignment, a vanished comet, and a planet